Okay, good morning, everyone. Hope you all are doing good. Yeah, ask your friends to join this session soon as possible. Post a message in your WhatsApp group that this live session is being started. And post your attendance in the comment section. So quickly I will revise what we have discussed in our last class. So in our last class we talked about standard library functions. In that we mainly focused on math library, math.h library file, standard library file, and we discussed many functions from that math.h library file. As I said, it is a short answer question. They will frame a short answer question from that predefined functions, whatever we discussed in our last class. Like we discussed your absolute value functions, then we discussed ceiling function, floor function, truncate function, round value function, power function, square root function. Okay, all these functions we discussed, all these categories of functions we discussed in our last class. Okay, with programs I have explained how these functions will work. With program example I have explained. Hope you understood that concept very well. So already the notes related to all these concepts from your first unit till the 5th unit, the complete notes is there on your blog. You can just go to the blog and you can download the content, whatever you need, whatever notes you need. You can download from my blog. Okay, so not only the notes, you can also find over there, you can also find the previous year university question papers. And with reference to that previous year university question papers, I have prepared a model question paper, so that also you can you can have a look on it. And unit wise important questions I have given, not only the unit wise important questions but also the solutions to all those important questions I have framed over there. So you can download those solutions and you can start the preparation for your external exams. In today's class, basically we'll be focusing, in my last class also I have given an overview on these pointers. What is a pointer and how it will work in our programming? I have given an overview, but in today's class we'll go into detail and we will see how these pointers can be framed. Like every other object in your C programming, these pointers, before their the inclusion into your program, they must be declared, they must be defined, and they must be initialized. Then only it is possible to use them in your program. Okay, these declaration, definition, and initialization will be applied not only to your pointers but to every other object. We started our discussion from variables. For a variable, we have to do the declaration. Declaration is nothing but giving the name, specifying the identifier, giving the name. Name is nothing but your identifier. So if you specify the identifier for a particular variable in your program, that is nothing but variable declaration. Then what is definition? Definition is nothing but specifying the data type, specifying the type of the variable, what type of value you are going to store into that variable. The type specification, we call it as variable definition. Then initialization is nothing but assigning the suitable value. Once the variable is declared and defined, unless you assign a value to it, it is meaningless, isn't it? It is not worthy. It is not worthy of using those variables into your program without initialization. Without initialization, we discussed those variables will hold the garbage value. Garbage value in the sense meaningless value, some unknown value or unwanted value into your program. So that is nothing but garbage value. Without initialization, all objects, all variables in your program are going to hold garbage values. So how come we make them usable? How come we make them useful? In the sense, by simply assigning a specific value, value of your desire, to that particular variable. Once the value is being assigned to the variable, that variable will become useful in your programming. So in that same sense, these pointers, even though they are holding the addresses, isn't it? Pointer definition I have given in my last class. I said pointer is also a variable. Pointer is also a variable, but it is a special type of variables. Unlike your regular variables, your pointer variable will not hold the values. Rather, it will hold the addresses. Okay, what does a pointer is going to hold? In the sense, it is going to hold the addresses. So far, we manipulated the data. We played with the data with the help of variable identifiers. Identifiers are nothing but variable names. But now on, in this pointers concept, we play with data values with the help of their addresses. Addresses are nothing but their pointers. Okay, so quickly we'll start your fifth unit, that is the pointers concept. There are so many concepts pending in your fourth unit as well. So like structures, unions, we have to discuss, and then the recursion also we have to discuss. But I thought the discussion of these pointers we have to do before that. So that is the reason why I'm explaining these pointers first. Then in our next class, that is, I think we have tomorrow also another class. So in tomorrow's class, we'll be discussing your recursion, structures, unions. Okay, in today's class, I will wind up these pointers. Okay, once the discussion of pointers is over, you can understand many concepts from these structures and from your recursion as well, because many of the concepts, they are interrelated with these pointers. So without the discussion of pointers, everywhere I have to tell you that we will discuss this thing in pointers, we will discuss this thing in structures likewise. So instead of that one, if we discuss the pointers at this point, it will become very easy for you to understand the recursion concept as well as the structures and unions. Okay, so quickly we will get into that and get into these pointers, and we will discuss more about these pointers. So if you see unit 5, we'll be discussing about pointers over here. Okay, it is an important concept, your pointers. We have more weightage for these pointers. They will ask a number of questions. I can predict that based on the previous year question papers. If you go and if you check, they are asking one LAQ from these pointers and minimum 2 SAQs from these pointers. So it is an important unit, and this unit, under this fifth unit, we will be discussing pointers as well as what we call self-referential structures. It is also one of the important concepts. So quickly note down, we will be discussing under this fifth unit the first concept, pointers, then self-referential structures, then files. These three concepts we have over here. The first one is pointers we will discuss, then self-referential structures we will discuss, and the last one, the files concept, we will discuss under this fifth unit. So today we'll be discussing pointers. Hopefully we will complete these pointers in today's session. Okay, So I just need more students, because as I said, every session is an important session, because we are covering many things which we can't able to do in your classroom. Because as you might have seen, I'm explaining every concept with the help of program execution. I'm showing you the direct execution as well, how these programs we can execute inside the compiler. That execution also I'm showing over here, which it is very difficult to show in your classroom without the help of a projector. So I request all of you to utilize this class as well as whenever you are free, because as we are saving this video under this page, whenever you are free, you just open this video and you can go through the concepts, whatever we are discussing and whatever I'm explaining. This makes you perfect in the concepts. If you watch it repeatedly, if you go through this video repeatedly, you will become a master in these concepts. And that mastery we need in order to accomplish your external exams. Without that mastery, without that level of knowledge, it is very difficult, okay, to face your external examination. Simply reading the notes, it is very difficult. As I told you, we don't have any concepts over here that you can simply mug up and you can write on your paper. So programs, it is very difficult to mug up, isn't it? That you have to agree. Okay, unless you practice them, unless you have the minimum knowledge related to that programming, it will become very difficult for you to mug up those programs. They are not mathematical calculations, or they are not some what we call chemistry formulas, physics equations. Okay, likewise, they are something entirely different, which you have not done. I mean, in your previous academics experience. Okay, this is a new thing. When we are studying about this PPS, it is a new thing what we are learning over here. And simply mugging up the programs, nowhere you can get through. So I suggest you to practice as much as possible and ask your friends to join this session. Okay, quickly post a message in your WhatsApp group that the session is being started, and ask them to come and join and post their attendance. So quickly, we'll discuss the concepts under these pointers. So yeah, these concepts, I mean, the first slide I have explained in your previous class. So I said all memory locations in your computer, all memory locations, they are going to have unique addresses, specific addresses for all those memory locations. And who will provide those addresses? In the sense, the manufacturers. Okay, the manufacturers who are manufacturing these computers, okay, they will provide the addresses to the memory locations, and they are unchangeable. We can't change the address value, I mean address of a particular memory location. It is highly impossible to change the address. Okay, so the address, who will provide those addresses for us? In the sense, the manufacturers of the computers, who are building, who are constructing, who are manufacturing these computers. Inside that memory, what they will do, for every memory location, they will give a specific address. So in your cities, if you consider our city as an example of computers memory, where every individual memory location is nothing but every individual building or house. Okay, every individual house, it is going to have a specific address. I mean, who will provide that address? In the sense, the city people. Okay, the city people, they will provide that address, or we can say the municipality or the corporation. Okay, they will provide those addresses to these houses. Can we change those addresses? No, we can't change, isn't it? I mean, according to the hierarchy, I mean, according to the organization of your house in a particular city, to where it belongs, accordingly they will give you a specific address. So in that same way, in your computer also, every memory location, based on its organization, how it is organized, how it is framed inside the computer memory, it will be given a specific address, specific memory address. Okay, that memory address we will use in order to manipulate the value, not the address. We are not going to manipulate the address. The address will remain intact. The address will remain unchanged. It is highly impossible to change the address. Okay, it will remain unchanged. It will remain intact. So what we do with the help of those addresses, because inside memory locations, what we are saving? We are saving the values. So far, whatever programs we have done, in those programs, we manipulated those values with the help of variable identifiers. Using variable identifiers, we manipulated the values. But now, from here on, inside these pointers, what we will do? With the help of memory addresses. With the help of memory addresses, we can manipulate the data which is there inside those variables. So here, if you read this statement, okay. So if you read this statement, every computer has addressable memory locations. This I already explained. I told you that in every computer, all memory locations will have addresses. Okay, a unique address, a distinguishable address. Okay, which is different for every memory location. Okay, so after that we said with the help of variable names. So far we manipulated the data with the help of variable names. Variable names are nothing but your identifiers. Okay, you have to, whenever I am saying variable names, whenever I am saying names are nothing but your identifiers, nouns in your programming language that I have explained. Variables are nothing but nouns in your programming language. So that is nothing but variable names. Okay. So with the help of identifiers, we have done the manipulations. But from now on, we said we are going to manipulate the content with the help of locations address, memory locations address. So why we are going for these pointers? What sort of advantages we have in the sense? They are the efficient way of accessing the data, accessing or manipulating the data. Okay, this is with the help of identifiers also we can manipulate. But if you manipulate the data with the help of pointers, that manipulation will become an efficient way. So variable manipulation is an efficient way of manipulating the data. So that you remember. So that is our first point of consideration. So why we are using variables, why we are using memory addresses in order to manipulate the data. Why we are using pointers. Whenever I say memory addresses, those are nothing but your pointers. So why we are using pointers to manipulate the data in the sense? Because they are an efficient way or efficient technique of manipulating the data. Pointers provide efficient techniques for manipulating the data in an array. Not only in the variable, but also in an array, we can manipulate the data in an efficient way with the help of these pointers. Okay. Okay. Inside functions also we can use these pointers. Functions we already discussed. Okay. Inside functions, why we use these pointers in the sense? In order to pass the address parameters. Okay. So with the help of these pointers, we can pass the address of the parameters. So that is nothing but your call by address or pass by address mechanism. Okay, to achieve this pass by address mechanism, so we discussed in interfunction communication. We discussed one concept in your functions, that is interfunction communication. So over there we discussed this thing, call by value, call by reference, or pass by value and pass by reference. So if you are implementing a technique known as pass by reference or pass by address, so that in order to implement we need pointers over there, because passing the addresses with the help of pointers only we can do. So passing the addresses to functions, how we are achieving in the sense? With the help of pointers. So pointers will also help in functions to implement pass by address mechanism. Okay. So we are going to discuss in your 5th unit only, we are going to discuss about this dynamic allocation functions, dynamic memory allocation functions. Over there also your pointers will play a vital role. Okay, that also very soon we are going to discuss in dynamic memory allocation functions. All dynamic memory allocation functions will work with pointers only. Okay, they will work with point only. So in dynamic memory allocation functions also we can use these pointers. So 4 different points I have given in order to give you the advantages of these pointers. The first one, these are the efficient way to manipulate the data inside a variable. So these are an efficient technique to manipulate the data inside an array. So not only to the variable but also to an array. So the third point, with the help of these pointers only, we can achieve pass by address mechanism in a functions. In interfunction communication, we have a mechanism known as pass by address. So how we are achieving that pass by address mechanism in the sense with the help of pointers only. Clear? So the next thing, in dynamic memory allocation functions, we work with pointers only. Okay, pointers are the way through which we are allocating the memory dynamically. So memory allocation, it is of two types: static memory allocation, dynamic memory allocation. So static memory allocation in the sense, whatever memory we have allocated to our variables, when we are using those variables in our program, so that memory allocation. So somebody posted that there was no chapter-wise solved questions I have posted in my blog. For your reference, if you want, I can show you that. But in the end of this session, I think you have not checked my blog thoroughly. If you go and check, there you will find that one. So unit-wise solved questions I have given. Unit 1 solved, Unit 2 solved, Unit 3 solved. Like that I have kept individually. So if you want, I can show you that one, but end of this session. So quickly we'll focus more on this thing. So pointers, we discussed these four advantages. So the next thing, so as I said, a pointer, it can be either a constant or a variable. Okay, it doesn't mean that it will, okay, when we are talking about pointers, it is a variable only. It can be a it can be a variable as well as a constant. Okay, so basically when we say a pointer, we are dealing with memory address only. We are dealing with address of the memory location only. So in that way, you remember. Pointer is nothing but, it is not the value, but it is a address. It is not the value, but it is an address. Okay. So basically all these pointers will work on based on pointer constant only. So I said every memory location is going to have a unique memory address. So that unique memory address is nothing but your pointer constant. So all memory locations, why we are treating them as constant? Because I told you clearly that changing the address is not possible. Address will remain intact. Address is unchangeable. Address will remain intact. I have given the example of your house address, your home address. So that home address will be given by the what we call authorities, municipality or corporation people. They will give the address to your house. So can we change that address? No, it is not possible. Based on the organization of your house, how your house is situated in a particular city, based on that situation, based on that location, they will give the address. So changing that address, it is highly impossible. If you change, even if you change that address, it will not give any meaning, isn't it? So in your house address, they will give you a specific number. That specific number we can't change, isn't it? So in that same way, all memory locations, they have an address address. So that address we cannot change. Clear? So because we can't change the address, that address will become a constant. Okay. So all pointers are built on those addresses only. Okay, on those addresses only. Again, so as long as we are talking about pointers, you have to remember that we are dealing with addresses. Okay. So the next thing, just give me a second. Just 1 second. So somebody said that I have not posted the solved solved questions on my blog. For her, this is my blog. So if you type this address in your address bar, you will get this blog. Okay. So over here, because I'm teaching multiple subjects, so you will get that related content as well. So if you come down, so this is this entire content is related to your Java. So you just come down. So this is also related to Java programs. Okay, this is other stuff. Some okay, Java previous university question papers and important question bank and assignment questions and all those things I have posted over here. So you just come down. So here programming for problem solving, as you can see. From here, your actual content will start. Okay, your PPS content will start. Okay, so I don't know who posted this message, comment. Quickly, I will try to get his, yeah, roll number 1 for you. Okay, programming for problem solving. This entire content we have, you can go to these web references. Here also you will get a lot of content for your understanding and for your preparation. Okay, so then we have this programming for problem solving, question bank solved. Understood? Question bank solved. So here unit 1 solved, unit 2 solved, unit 3 solved. Likewise, I kept all the something they are posting. Just give me some time to read. Okay, so here you can get all the solved questions. I will open this for you. So unit 1 solved. As you can see, it is opening the PDF document. Here inside that unit 1, see these SAQs. SAQs I have taken and I have solved. So these number conversions I have solved, and this is how this particular thing will be converted into a switch case, that also I have solved. So define assembler and how it is different from a compiler. I have given the explanation. Algorithm to find the maximum in 3 numbers. See, all these questions, unit-wise important questions, which they have asked in the previous year university question papers. I have selected those questions. See, for a single question, in how many different ways they can frame the question for a single topic. So this sum of n numbers in an array. So if you this program we have done in the lab as well as in your classroom also have explained sum of n numbers in an array. So in how many different ways they are asking that question? The 3 different ways I have given over there, and simply I have framed the answer under it. So write a program to find the sum of n numbers without using an array. So this is one thing. Write a program to find the average of n numbers without using an array. That also I have given. And write a program to find the maximum and minimum numbers among n numbers without using an array. So for all those, the same solution, I mean, this is 1, this is 2, and this is 3 I have given. So just go through the blog before making any comments, before giving any statements. I request you to thoroughly check the blog. When I'm saying something, it means I have done something for you. Then only I will give such kind of things for you. Okay. So first you go to and first you check over there, then you make the statement. Simply you're coming and you're saying, sir, you have not put anything, and you're saying that you put. I have done. This is 14th of December. I have done. As you can see the date over here. When I have done this one, on 14th of December last year. Okay. So the same principle, same concept will apply to you. Inshallah, very soon I am going to solve the last semester question paper also, that I have already solved. I will include inside your blog, or I will post it into your WhatsApp group. Okay. So over here, your lab programs, Viva questions. Okay, from week 1 to week 11, all these lab programs you have to practice. All these lab programs I told you I have to write in your records just to save the time, because you are getting this free time in this vacation. So I told you to write all the programs in your record. So quickly do that one. Okay, this is unit-wise notes. See, this is your syllabus, PPS syllabus. This is your lab syllabus. Okay, lab syllabus, programming for problem solving. And this is your theory syllabus, programming for problem solving. And this is unit-wise notes. This is your unit 1. The name of unit 1. The topics what we are going to study in this unit 1. Okay, unit 2, unit 3. Okay, this unit 4 and unit 5. Now we are dealing with these pointers. The complete notes I kept over here. Okay, previous year question papers. This is my model question paper. This is OU question papers. Whatever statements I'm making, just go there and see. Without seeing only you're coming and saying that, sir, you're making fun that, sir, you have not posted anything, and you're saying that you have posted. How come it is possible? Okay. So over here, we were discussing about these pointers. So as I said, a pointer's address is a constant. Because we can't change its value, we are treating it as a constant. So like every other constant, okay, your integers, they are constants, because integer values, when we are not talking about integer variables, when we are talking about integer values in the sense the whole numbers, whatever we are using in our programming, we can't change. 20 means it will remain 20 only. We can't make it as 25 or 20, 30 something, isn't it? 20 means it will remain 20 only, the count 20. So that will remain like a constant in your program. So in that same way, your address will also becomes a constant. Okay. So every time, whenever you are executing a program, all the variables will receive a unique address. Okay, a distinguishable address. Okay, for their for their values, because in order to store the value, we need memory location. So when the memory location is assigned to your variable, that memory location will have a address. So the same I have explained over here in this statement. See, inside a program, all variables inside your program, whenever you are executing your program, runs in the sense executing. Whenever you are executing your program, all variables will get different addresses. Okay, all variables will get different addresses. Okay, so then pointer constants are drawn from the set of addresses. As I told you, manufacturers have given the memory locations a specific address, a unique address. Your variables will occupy those memory locations. When a particular variable is occupying a particular memory location, what address that memory location is holding, that same address will be given to your variable. Okay, so I will give you with the help of a diagram that explanation. So quickly see this diagram. So all these are your characters. Okay, all these are your characters, capital letters, small letters, as well as there are some special characters. About these things we discussed in your class. When we discussed about these characters, we discussed about these things. Okay, all these things are your characters. So when you make a particular variable, so here this is my variable. Okay, what is my variable name is a character. This is your identifier, variable name. This is your variable name. So when you declare a variable in your program, these are all character constants. Okay, when you declare a variable in your program to store a particular character value, let us say this G. We are storing this G into that character variable. So when you are storing that character variable into that character constant into that variable, what will happen? You have to give the identifier. That identifier is nothing but this a cap. This is your variable name. and whatever constant we are storing into that variable, we call that constant as a value of that variable. Understood? Value of that variable, and we call this entire thing variable value, variable identifier, and memory location as a variable. We call this entire thing as a variable, and every variable, every memory location in your computer will have a specific memory address, an associated memory address. Who is giving this address? In the sense, the computer manufacturers. We are not allocating, we are not giving this address. What we are giving to this variable? This constant value, whatever value this variable is assigned, that value, that assignment, we are responsible. But when it comes to the addresses, who are responsible? The manufacturers are responsible. We are not responsible. Clear? So simply, whenever we are taking a particular memory location from your computer's memory, that memory location will come with this address. Okay, will come with that address. Suppose if you are looking for a house in Hyderabad, suppose if you are looking for a house to live, then you will become the value because you want to stay in that house, isn't it? So then you go to some what we call the tenants. Then what those tenants will do? They will rent you a house. They will charge every month for that, like house rent. Okay, isn't it? They will charge every month the house rent, and then you will take as a paying guest, you will take that house. So once you take that house will come up with an address, isn't it? A unique address will come with that house. So do you have such a flexibility that I don't like this house address? Can you change this house address? Do we have such kind of flexibility? No, we don't have such kind of flexibility. So whatever house they are giving, that house ultimately it comes with an address, and we have to occupy that house if we are interested in that, isn't it? So changing that particular house address is not in our hand. So in that same way, whenever you are defining a particular variable in your program, that variable is going to occupy some random memory location from your computer's memory, and that random memory location will have a unique associated address. So that address we are calling it as a pointer constant. Clear? Hopefully. So we'll go to the next slide and we will see more in detail. So that is what, see. So here, this is your computer's memory, and all these locations, they are contiguous in nature. Like in a street, how the addresses, how the houses are going to be situated. I mean, this first house address, let us say if it is 101, then what will be the second house address? It will be ultimately 102. You just go to your street and you will check all house addresses, they will give in a sequential order. So in that same way, in your computer also, all memory addresses, see over here the memory address is starting from 0000. So the first location's address, if you treat this 000, then the second location's address will become all 5 zeros followed by 1, isn't it? 5 zeros followed by 1. So in that same way, all these memory locations will have their addresses. And all these memory locations are contiguous in nature. Contiguous in the sense attached to one and other. Okay, in a sequential manner, they are, all these memory locations are contiguous, attached. Okay, adjacent to one another. Okay, in that way we can say contiguous in the sense adjacent to one and other. Okay, so in that same way, whenever you are declaring a variable, in your computer, in your program, that variable will take any random memory location. There is no guarantee that what type of memory location your operating system will allocate for this variable a character. It is completely random. It is completely system dependent. Whatever memory location is free, whatever memory location is usable at that point of time, your computer will ultimately select that memory location and assign to this a character. Understood? Assign to this a character. Okay, somebody is commenting. Yeah, if you have any kind of doubts, you can comment. No issues. Any clarifications you need, you can post in the comment section. I'm here to help you out. Okay. So from these character constants, okay, from these character constants, we are declaring a variable to store this G. So that G will be stored inside the memory location, and that memory location will have a specific address. This is your pointers concept. Okay. So now, being existed in computer, a pointer constant can be retrieved and saved inside a variable. As I told you, manipulating the pointer's address is not possible, but we can save that address into a particular variable. So that saving is nothing. I mean, in order to save that address, we need to declare a pointer in our computer. Okay. So in order to retrieve a particular, so suppose if you have a variable, okay, if you have a variable, how you can get the value of the, I mean, how you can get the value of that variable? Simply by using that variable name. And how you can get the address means you have to use the address operator. Already we are quite familiar with this address operator because we use this address operator in your scanf statement. In your scanf statement, scanf we said it is a postman function. Postman will need the address. Before delivering the letter, he needs the address. So your scanf function, it is quite similar to your postman. So in your scanf function, whenever you are reading the values, you are reading inside variables. Okay. So over there, what you have to do, you have to provide the address of that particular variable. So how we are providing the address, in the sense we are using this ampersand or address operator. We also call it as address operator in our programming. So with the help of that address operator only, we are specifying the address of a variable. So quickly we'll do a simple program for this to understand how these pointers can be declared, how these pointers can be defined, and how these pointers can be initialized with the variable address. And we will print the address also to know how, see, in order to print the variable's address, this last statement you quickly read. Okay. So this is clear, right? In order to get the address of a particular variable, what we have to do, we have to prefix that variable name with this ampersand. So here you can see the syntax I have given. Syntax is nothing but variable name prefixed with this ampersand. Simply prefix this ampersand before the variable name to get the address of that particular variable name. So in that way you can get the address of a variable. So to print the address of a variable on your console screen, on your output screen, how we can print the address? Simply use this and percentile P. For printing integer values, percentile D. For printing character values, percentile C. Float values, percentile F. Double values, percentile F. How can we print the address? In the sense, percentile P you have to use. Quickly we will practice this one. Okay. I will open your Dave CPP. See, follow these concepts thoroughly. A bit quickly I will move from here on. So how we can get the address? So this is your Dave CPP. I'm opening a new file. Okay, so I'm writing a simple program. Okay, so then what we have to do? Declare a pointer. First of all, I'm declaring a variable. A equals to sum 20. This is my normal variable, integer variable. Now I want to store the address of this variable A. So in order to store the address of a variable A, so if you want to store the address of this variable A, what we need? We need a pointer. Okay. So for declaring a pointer, you need to know the type of that pointer. So how can you know the type of that pointer? Okay, it is based on what type of value you want to store into that pointer. So here, as you can see, I want to store the value, I want to store the address of a integer variable. So what type of pointer I have to declare? I have to declare an integer pointer. How we can declare? This also I have explained in my last class. Simply put that type followed by star. Okay, now this PTR, okay, this PTR is a pointer of type integer. So when you are declaring a pointer of type integer, what address you can store into that pointer? You can store the address of an integer variable only. You can store the address of an integer variable only into that pointer. Having a character variable, let us say you are having a character variable. I'm also declaring a character variable. Character ch equals to a. So now this character variable ch is holding a character value a into it. So now into this PTR, can I store the address of this ch? No. Why? Means because my PTR is of type integer. PTR is a pointer of type integer. So it can hold only the address of an integer variable. It can't hold the address of a character variable. Concept is very simple. Suppose if you have an integer variable, declare an integer pointer to store the address of that variable. Suppose if you have a character variable, declare a character pointer to store the address of that character variable. If you have a float variable, then also you declare a float pointer. Okay, short variable, short pointer, long variable, long pointer. In that way, you have to declare a specific type of pointer for storing that specific variable's address. So over here, now if I want to store the address of a character variable, what I have to do? Just declare a character pointer. How can we declare a character pointer? Character star. Okay, character star. So now CPTR, C in the sense character pointer. So next thing, I'm declaring a float variable. Float equals to some 12.345. Okay, 12.345 is my value. Float variable name I have not given. Float f equals to 12.345. So to store this float variable's address, I need a float pointer. So float star, float star, declare the float pointer fptr. So now fptr will become float pointer. Likewise for short also same thing, for long also same thing, for double also same thing. You have to declare a suitable address. So now what I will do, inside this PTR is your integer pointer. So what can I save into that pointer? Can I save the value of a? So if you put like this, what this a will represent over here? So focus over here. So when you put simply a over here, what this a will represent? A will represent the value. Can I store that value into this PTR? No, storing the value, it is not possible because PTR pointer is capable of holding the address. So how can I get the address of this a variable? Simply by placing ampersand before that. If you put the ampersand, that will give the address of this a variable. So now that address we are storing into this PTR. So next thing, same. CPTR can hold the address of, okay, can hold the address of ch, character variable. Then fptr can hold the address of, float f. So likewise we have saved the addresses. So now I want to print their addresses as well as values. So how can I get the address? How can I print the address? So first of all, addresses. We are printing just the addresses. In order to print the addresses, I told you percentile P we have to use. So addresses of integers. So first we are printing the addresses of integers. One with the help of pointer and one with the help of variable. So my address, integer variable, what variable we have? A. So how can I print the address of integer variable? Ampersand A. Okay. So then I want to print that same address with the help of a pointer. So where I have stored that address ampersand A inside PTR. So for PTR, I want to get the PTR's content. I don't want the PTR's address, isn't it? Inside PTR, we have the address of A. So simply print PTR. PTR itself is holding the address of A. So that's it. So then go to the next statement, printf. Okay. Then addresses of character. That also you can print with the help, because we are printing addresses. We are not printing the content. Okay. So then comma. So inside ch is holding value. So print the ch address. So then I want to print the address CPTR because CPTR is holding the address of character. So the next thing, printf, the last one, addresses of float, addresses of float, percentile P, percentile P, okay, comma, and percent, what is that? Inside F we have, right? And percent F will give the address of F variable, then FPTR will also give the address of F variable. So in this way, you can print the addresses. So quickly we will see what output you will get from this program. Then we will try to print the value, get CH. So quickly save this one. Okay, here you can put CLR, SCR. So that I can't use over here. So system of CLS. So in this way you can use. Quickly save this program. Okay. So with today's date, I will save this program, and I think it is already saved. No, it is not saved. So I'm saving this program with today's date. So test 30. Test 30.c. Hit enter. The program is saved. Go to tools, execute, compile. It's taking time. Yeah, compilation successful, as you can see over here. Then go to tools, execute, run. So it is. It is taking time to print that addresses. We'll see for some more time. Yeah, it is printing. Okay, because I have not used \n, the output is becoming clumsy. So to make it more understandable, what I have to do, I have to put \n over here. So quickly I will do that one so that we can get the output in a fresh line, \n. So then save, compile, successfully compiled, execute and run. As you can see here, it is printing the address. So as I told you, address of integer. So what we are printing here, see, address of integer. So that is nothing but address of a variable. Address of a variable is this one we are getting here. This entire thing is the address of. This is something machinery stuff in hexadecimal format, because you are getting E and F also. As you can see, numerical values, E and F also you are getting. So E means how much in hexadecimal? Can anybody? E means how much in hexadecimal? F means it is nothing but 15, right? From 0 to 10, 0 to 9, then 10 will become A, 11 will become B, 12 will become C, 13 will become D, 14 will become E. 14 is E, 15 is F. So in that way, all your memory addresses will be in hexadecimal format. So this is an hexadecimal address. This will represent your memory locations address. A, wherever it is, storing this A variable inside your computer memory, that A variable is holding this particular address. So that same thing we are assigning to PTR. So as you can see over here, inside PTR, it is a pointer, and we are storing the address of A into that pointer. So that is the reason why here this percentile P, I am printing the address of A. This percentile P, I am printing the PTR variables content. So PTR variable, PTR pointers content are nothing but A's address. So A's address, this same thing we got, and PTR's content, this same thing we got. The reason, we initialize this PTR with address of A. So this PTR is a pointer of holding integer variables address. In that same way, CPTR, here I am printing CH and CPTR. CH variables address is this one. How we are getting that address? By simply prefixing %. The same thing we stored inside this CPTR. So you are getting that address inside this CPTR. Then fptr and f. Address of f variable is this one. How we are getting this address? By prefixing %. The same thing we are printing at this percentile p. So then fptr, it is a pointer holding the address of f, because we have initialized fptr with f's address. So that same address we are getting. So as you can see, this address is same. This address is also same. This is also same. So in this way, you can get the addresses of a variable. So now, how can we get the values from those addresses? How can we get the values from those addresses? Quickly try to understand. Percentile p. So no, printf \n value of integers. So now, to get the value from a variable, do we have to prefix percentile d, that ampersand symbol? Do we have to prefix that ampersand symbol? No, we don't have to prefix, because a itself will give the value of a. Inside a, whatever value we have, inside a what we have? 20. That 20 will come over here. This percentile d will be replaced with this 20. A's content, a variable's content. So now, using PTR, how can I get the value? So if I put PTR over here, what it will give? PTR will give the address, isn't it? PTR will give the address. That address, it is an hexadecimal value. That address is an hexadecimal value. If you use percentile d over here, that hexadecimal value will be converted to integer value, and that integer value you will get over here. That is not our intention. Using this PTR, I want to retrieve the content of this a, isn't it? Because PTR is holding whose address? PTR is holding A's address. So using this PTR, I want to get the address of A. So over there, we use the indirection operator. This star operator, what it will do? On a pointer, when you apply this star operator will retrieve the value of that particular address. PTR is holding A's address. So star PTR will get the value of A. PTR will give you the address of A. Star PTR will give you the value of A. Okay, in that way, in that sense, you have to remember. So the next thing, printf \n, same thing, value of character. How can we get the values? For printing character values, percentile C. So from ch variable, I can get directly. But from cptr, star cptr to get the value. So in this way. Next is printf, same thing, \n, okay, value of float. How can we print the values of float? Percentile f. Okay, then from f directly we can get the value. But from fptr, it is a pointer. So apply indirection. Indirection of fptr will give you the value from that fptr pointer. Okay, now you save this, compile, no errors, hopefully no errors, then tools, execute, run. Yes, if you see the output, it will print over here. So same thing. Yeah, here you just try to understand. Okay. See here, value of integers, percentile D. A is having whatever value, that same value it is printing over here. A is holding 20, so 20 you are getting over here. Then PTR is holding the address of A. If you apply the indirection, it will give the value of A. So that value of A is nothing but 20. So inside that CH, we stored A character. So inside this CH, we have A character. Then inside CPTR, we are having address of CH. If you apply indirection on address of CH, you will get the value of CH. The same thing we are getting over here. Inside F, we have this float value, 12.345000. Inside this FPTR, we are having the address of F. If you apply the indirection on that address of F, you will get the value of F. That is the reason why we got the same thing in both cases. So in this way, you have to remember. Simply, how to get the address of normal variable? A. Pointer variable, type followed by star. You have to use in that way. So then, how we are storing the value inside, how we are storing the value inside a variable? Simply by using assignment operator. How we are storing the address inside this PTR? prefix the variable name with ampersand. If you prefix the variable name with this address operator, with this ampersand, you will get the address of A. That address of A we are storing inside the PTR. So now from this PTR, if you simply print the PTR with percentile P, you will get the address. If you want to get the value from this PTR, apply the indirection that we have done over here. Ampersand F will give the address of F variable. Indirection on PTR will give the value from that PTR. So in that way you have to remember. Quickly we'll go to the slides and we will see more in detail. So this is about pointers. Simply address operator will give you the address of a variable. You have to put ampersand variable name to get the address, and to print the addresses use the percentile P. All these things we have seen with the help of program. So this program just now I have explained more in detail. So over here what I am doing, I am declaring two variables of type character and I am printing the addresses. I'm not assigning any content, and I'm printing the addresses. So don't think that every time you will get the output like this. You will get some random value, because memory locations for these variables are random in nature. What memory locations the computer will select at the execution time, we don't know. So accordingly you will get the addresses. Some random addresses you will get. Okay. So pointer variables, already we have seen how we can declare. See, uninitialized pointer variable will hold some garbage value. So that garbage value will make you to point some garbage memory location. So to avoid that one, what we will do, we'll make a pointer null so that it will not point to any memory location. So this special type of pointer, null pointer, we have NULL, null. So it is a standard variable defined under stdio.h, as you can see over here. This null is defined inside stdio.h. Okay, so yeah, all these things we discussed how we can declare a pointer variable. So suppose if you have an integer variable's address to store, you have to declare an integer type of pointer. See here, integer type of variable's address can be saved into a integer type of pointer. So to store address of a variable, we need a special type of variable, that is pointer variable. So whenever we are dealing with addresses to store, we are talking about pointer variables. This also we discussed. Okay. Yeah, we can't save multiple variables addresses into a single pointer. In order to store multiple variable addresses, we need multiple pointers. Every pointer is capable of storing a single variable's address. We can't store multiple variable addresses. Okay, suppose if you have a single variable A, in order to store that A variable's address, you have to declare a separate pointer. Another variable you have like B, you want to store the address of that B variable also. So declare another pointer to store the address of that B. Don't think that you have already declared a pointer, an integer pointer, and using that pointer, the same pointer only, you can store multiple variables addresses. It is not possible. For every individual variable, you have to declare a separate pointer to store their addresses. Okay, in that sense, you remember. Quickly, we'll go to the next slide. So here, yeah, this we discussed, right? Yeah, this also we discussed. Yeah, accessing variables through pointers. This also I have explained. So the indirection operator, see, we call this operator as indirection operator, the star operator or indirection operator. Ampersand operator is your address operator. To get the address of a variable, we are applying ampersand operator. So if you have an integer variable, let us say A, how you can get the address of this A? Simply put ampersand. Understood? Simply put ampersand before that variable, so that this ampersand A will give address. It will not give the value. Address of variable A. This will give the address. So how you can get the value of A? Simply put A itself. Don't prefix anything or don't suffix anything. Simply if you put A, you will get the value of that A. Understood? How you can get the value? Simply by using the variable name. How you can get the address? By prefixing ampersand. So suppose if you have the pointer PTR. So this PTR indicates what? PTR indicates the pointer variable name. So if you use PTR in your program, if you are using PTR in your program, this PTR will give you what? Address. PTR will give you address because it is a pointer variable and holds the address. Okay, simply if you put the PTR, it will give the address. Then how to get the value? Yes, prefix the indirection operator. This operator. We have to prefix indirection operator. Prefix indirection operator to the pointer variable PTR will give you what? It will give you value. In this way you remember. Prefixing the address operator before the variable name will give you the address. Don't prefix anything, simply use the variable name will give you the value. Okay, don't prefix anything, simply use the pointer variable name will give you the address. If you prefix the indirection operator will give you the value. So here, this is the purpose of using address operator as well as indirection operator. Address operator to get the address. Indirection operator to get the value. Okay. So this is something about address operator and indirection operator. Quickly go to the next slide. So over here you see. So here what we are, see. Yeah, this thing you have to understand. So here I said, yeah, I will open another thing, MS Paint. Quickly see here. Okay, so declaring a variable int a equals to 20, then declaring a pointer int star PTR. So now if I do like this, PTR equals to and %a. So now here PTR is a pointer of type integer and holding the address of a. So if I say, if I say like this, and %a, what this and %a will give you? The address of a, which is nothing but your PTR, isn't it? Because PTR is holding the address. So these two things are same. These two things are same. Okay, and %a is nothing but your PTR because both are holding the addresses now. Or if I say simply a is same like what? Applying the indirection on PTR. Applying the indirection on PTR. So this is one statement. Another one, if you say simply a, it is also same like star and %a, because and %a will give you the address of a, that is nothing but PTR. Apply star on PTR will give you the a only, value of a. So like this. So this statement, this is very, very, very important. You have to understand these things. Understanding of this thing is very important, as I'm telling you. This particular statement, this block is very important. And %a is nothing but address of a, that is nothing but your pointer, as you can see over here. Okay, this represents this one. Okay, next thing, a is nothing but star a PTR, because we said on an address, okay, if you apply the indirection operator, you will get the value. That I will give you over here. So if you have the variable name and applying and variable, I'm generalizing this statement now. Variable name and applying the and will give you what? It will give you what? It will give you the address. It will give you the address. So applying star on variable. So this is not address, this is variable's address. Variable, like this you remember, will give you variable address. Variable address. So applying star indirection on variable address will give you what? Will give you variable value. Will give you variable value. Okay. So after these two statements, apply star on applying variable name will also give you what? Variable value only. Because applying ampersand on variable name will give you variable address. See, applying ampersand on variable name. So this statement, as you can see, this entire thing, applying ampersand on variable name will give you what? You can replace this entire thing with variable address. Variable address will come over here. So if you apply indirection on variable address, you will get what? Variable value. That's it. The same thing I have written. So these two operators are inverse to each other. So star and ampersand, they are inverse to each other. They are opposite to each other. So apply the same thing. So applying these two on a single variable will give you that same variable. So these two operators, they will cancel each other and will give you the same variable. If you apply star as well as ampersand, they are opposite to each other. They will cancel each other and they will give you the same operator. Okay, the same variable. So this statement, it is also very important and you have to remember this particular thing. Okay, this statement is also important. You have to remember this one also. So these two things you just remember, this box and this box. Hopefully you got some idea about these pointers. So quickly we'll go to the next slide and we will see what we have over there. Many concepts I have explained. So this is what? X is a variable. X is a variable and I'm making 2 pointers here. Okay. X is a variable of type integer. So how I'm declaring that X? Simply I'm doing like this. Int X. I'm not initializing anything. Then what I am doing? Okay. Int star ptr and q. 2 we are declaring. Int star ptr and int star p and q. P and q I am declaring. Then what I am doing? Okay. P is equals to ampersand x. P is equals to storing the address of x into p. Okay. Then the same thing, p is equals to ampersand x, same I'm doing. So after this thing, after doing like this, after writing these 4 statements, you will get a memory scenario like this. Okay, x, so far we have not initialized anything. So what it is holding? Question mark, a garbage value. Then p and q, both are pointing to that x because both are holding the address of x. So this is not y, this is also x. P is also x, address of x. Q is also address of x. Q, this is q. Okay. P is also address of x and q is also address of x. Simply I will write this statement once again. Q is also holding what? Q is also holding address of x. Okay. So both my pointers P and Q, because I have declared 2 pointers, int star PQ. So both these PQ are pointers. P is holding x address, Q is also holding x address. So PQ are pointing to x and x is holding nothing so far. After this statement, when you say x is equals to 4, what will happen? Yes, x is holding 4 now and PQ are pointing to that 4. Okay, if you do x equals to x plus 3, you are incrementing this x content. Okay, x is holding 4 now. X is holding 4. If you do 4 plus 3, what will happen? You will get 7. That 7 you are storing again into x. So x is holding 7 now and PQ are pointing to x. Now I am saying star p over here. P is what? P is holding x address, as you can see over here. P is holding x address. So if P is holding x address, if you apply indirection on that P, what will happen? Indirectly you are pointing to that x only. Into that address of x, you are keeping 8. So what will happen? That same memory location will get affected. that same memory location will get affected because P is pointing to that X only. So P is pointing to that X only. So P is holding the address of X. So on that address of X, you are storing the X. So if you are storing into that address, it does mean that you are changing that address content, that memory location content. So now X will hold 8. After that, what I am doing? So here you can see star and X, star and ampersand. What it will do? They will cancel each other, and you will get X only over here. So what is that X? Into that X, what I am doing? Star Q plus star P. Star Q is nothing but Q is holding address of X. Address of X indirection. You will get 8 over here. Because as you can see, address of X is holding 8. So 8 you will get. Same thing. Star P. P is nothing but address of X. You are applying indirection on address of X. You will get value of X. That is 8. 8 plus 8, 16. So X will get 16. After, X will get 16. So now, before applying this statement, X is holding 16 and PQ are pointing to that 16. So now what I am doing, I am applying this star operator. This star indicates the multiplication operator over here. Okay, this star is not indirection. Star is having multiple purposes. Over here, the star will act like an indirection. Here also, star will act like an indirection. But here, when you use between two values, when you use this star, it will act like an multiplication operator. That you know. Because using this multiplication operator, we performed the multiplication many times. Understood? So this statement also you have to understand. This is thus the continuation. So star and ampersand of X is same like X because these two will cancel each other. These two will cancel each other and you will get only X. Okay. Then X is equals to star P multiplied with star Q. Indirection P multiplied with indirection Q. Indirection P is nothing but value of X, that is 16 because X is holding 16. Then multiplied with value of Q, that is nothing but again value of address of X. Value of address of X is nothing but value of X, that is 16. Same thing you will get over here, 16. 16 multiplied with 16, you will get 256. So in this way, you have to analyze these statements. Hopefully you got. Quickly, we'll go to the next statement. Yeah, how we are declaring and defining the pointer. This I have explained. Many times I have explained after the discussion of these pointers. So in order to declare this pointer, we have to use this star or asterisk. We also call this symbol as asterisk symbol or indirection symbol. So that type followed by the asterisks will declare the pointer variable. So this identifier, okay, prefixed with this type star will declare a pointer variable. This is the declaration of your pointer variable. You have to understand this one. This we have done many times. Normal variable declaration, simply we use identifier prefixed with type. Okay, type followed by the identifier. Over here, type star followed by the identifier. That is the only difference between declaring a normal variable and a pointer variable. Over here, this is A, is a normal variable holding Z value. This character star P is a pointer variable. So far, it is holding nothing. Okay, likewise, int Q. Int, this is capable of holding this integer n. How you can make that Q to hold this n's address? Simply what you have to do, Q is equals to ampersand n. Like this you have to do. So now what will happen? If you do like this, Q is equals to ampersand n, this arrow will point this n like this because it will hold the address of that n. Here also same thing. How can you make this P to point this Z in the sense, this memory location in the sense, P is equals to, we have to make address of A. P is equals to ampersand of A. Now this will point here. So here also same thing. Float R we have, float star R we have. This R is a pointer variable and it is pointing to nothing. How you can make this R to point to this X is the sense, simply make that statement. How you can? R is equals to ampersand of X. So in that way, it is going to point the float variable. Understood? So the next thing, so this is just the demonstration of printing the values as well as addresses. This is also I have given. In that program only I have explained. To print the value, we have to use percentile D. To print the address, we have to use percentile P. A will give you the value and %a will give the address. The same thing here we are getting. So the next thing is what? Star PTR will give you the value. Applying the indirection on pointer will give you the value. PTR will give you the address. Simple thing. PTR will give you the address. Star PTR will give you the value. So this simple discussion, I mean, with the help of program also I have given. Next thing, the declaration versus indirection. So over here, star operator we are using for two different purposes. One is to declare a pointer, int star. What this int star will do for declaring PTR. PTR as a pointer, we are using this star, that is asterisk symbol. Okay, it is having another functionality to indirect a pointer. As an indirection value address operator, as an indirection operator also it will work. Okay, over here, star APTR will give you the value from this APTR. So like this, star indirection operator will act like an value retrieval thing. Over here it is used to declare a pointer, over here it is used to indirect a pointer. So those two are different uses of this asterisk operator. The asterisk operator can be used in two different contexts, one for declaration and one for indirection. This is not redirection, this must be indirection. Here some error it is there. I will rectify that error. It is not redirection, it is indirection basically. Okay, so redirection is something assigning the address, but using star operator we are not assigning the address. Redirection with the help of what we are achieving, with the help of %, we are achieving. Okay, because this will assign the address, %, operator or address operator will assign the address. So this is used to redirect the value. But whereas asterisk, it is indirection operator. Okay, for indirection purpose we use this asterisk operator. So two different functionalities. We use this asterisk operator in two different contexts. The first one is to declare a pointer and the second one is to indirect the value. Clear? So the next thing, initializing a pointer, already have explained. Without initialization, a pointer will also have an unknown garbage value. So how can we make them to hold some specific value? Simply by initializing the address of a particular variable to it. Okay, how we can do means simply by using %, prefixed with the variable name. So if you have a pointer PTR, declaring a pointer PTR, see how we can declare int star PTR. Int star PTR. So if you declare like this, int star PTR, what this PTR is holding now? So far we have not assigned any address to this PTR. So PTR will hold garbage value. PTR will hold garbage value. Understood? PTR will hold garbage value. I will explain this thing with more clarity here. Writing it is not coming. So what I will do, I will take a paint window. With the help of paint window, okay, I will explain. See here, you have to understand this very clearly. Okay, first what I am doing, I am declaring a regular variable a. So now a is holding what? After this, a is holding what? A is holding garbage value. Garbage value. So garbage value already I explained, some unknown meaningless value. Okay, then how we can make a to point some specific value? The first way is you can assign 0. So now the a will hold some 0. Okay, this you already know. Or you have more specific value like this, you can do 20, you can initialize. So in that same way, when we declare a pointer to store that variable address a, how we can declare the pointer? The first declaration int star, because we need an integer type of pointer, int star aptr, because this this pointer is going to hold the address of a. That's why I said aptr. So now aptr is capable of holding the address of a. So next thing over here, aptr will hold what? So far have we done any initialization? No, we have not done. So aptr will hold garbage value. Here also aptr will hold garbage value. Clear? aptr will hold garbage value. So now how we can make it to point to nothing? So you can't initialize aptr equals to 0, because 0 is a value. But we want address because APTR is capable of holding address. So, but over here, 0 is a value. So, doing like this is an error. It is an error. You cannot initialize a value to a pointer. So, how we can make this pointer so that it will not hold the garbage value, but will hold a default value in the sense null pointer. That's now I said. Null is a pointer, not, no pointer, no address. Null in the sense no address. No address. Okay, so doing like this will make you this. Okay, doing like this will make you the APTR pointing to nothing. Okay, so now if you want that APTR to point specifically to that A, how you can? %of A. In this way you can do. So this is in terms of normal variables. I have given the explanation, and this is in terms of what? In terms of, this is in terms of pointer variables. So in both the ways you can play with. This is for pointers and this is for normal variables. Understand, try to understand this one. Declaring a normal variable, not assigning anything, variable will hold the garbage value. You can make it to, you can initialize to 0 so that it can hold the 0 value. You can assign a more specific value to it so that it will be assigned, it will be holding that specific value. Same in case of a pointer, if you are just declaring the pointer but not assigning any value, it will hold the garbage value. So to make it default initialization, you can't initialize 0. Initializing 0, 0 is a value, but APTR needs addresses. So doing like this is an error. So how you can make it to point a default address, or simply we can say no address. So by initializing that APTR to null. Null is a no address kind of thing. It is initialized inside your stdio.h. Okay, then if you want that APTR to point to a specific address, so that specific address, how I am getting? Of this A variable. So simply prefix that & symbol before that variable name to get the A's address, and that A's address will be initialized to that APTR. So in that way you can do. Next slide. Yeah, you can have pointers to pointers. This we will discuss in our next class. Hopefully you enjoyed this session, and I request you to post the attendance. And if you have any doubts, you can ask me. And don't think that the notes is not there. I have kept the complete proper notes, okay, suitable for your semester, this semester, on the blog. You can go there and you can download, you can check. If you have any doubts in the notes, any doubts in my lecture, any misunderstanding, you can clarify those things. I'm waiting for your attendance as well as waiting for your doubts. You can ask. Yeah, somebody is asking me that address is permanent or temporary. See, as long as you are using that address inside your program, so that address will remain as long as the program will execute. Once the program execution stops, that address will be freed. So when the address will be freed, it doesn't mean that it will be deleted from your computer. As I said, every memory location will have a specific address, and that address is permanent. Inside your computer, it is permanent, but inside your program, it is temporary. When you are storing that address into a pointer, that pointer will store that address as long as your program is executing. Once the program execution stops, that address value will be deleted from that pointer, will not be deleted from your computer. Because just now I said, I mean, in the beginning of this session, I said addresses we can't change. Addresses we can't change. Deleting, it is also a change. Isn't it? Deleting from the computer, it is also a change to that address. We can't delete, we can't change, so we can't delete. They are permanent inside your computer, but in your program, they are temporary. In your program, all variables will hold temporary values only. Okay, So if you are assigning, so here what I have done for your understanding, if I have initialized a with 20 value. Okay, for how long this 20 value will remain inside this a, in the sense as long as your program is executing. Once the program execution stops, this 20 value will be deleted from this variable a. Does it mean that this 20 value will get deleted permanently from the universe? No, we are having 20 as a value. We are counting 20 as a value. It will remain intact. We can't change the 20, the count 20. It will remain 20 only. Isn't it? So in that same way, whenever you are assigning this ampersand a to this PTR, so this PTR will hold that address of a into that PTR. How long this PTR will hold that address? As long as your program is executing. Once the program execution stops, this value of a, address of a will be removed from this PTR. It doesn't mean that that PTR is, that address will no longer exist. That address will exist inside your computer, but in your program it will not exist. Hope this answers your question. Explain on once again. Should I explain the complete pointers concept once again? I don't know his roll number. Specifically, you mention any particular topic or any particular concept. If you have not understood, that you mention. Any more questions you have, you can ask. Yeah, this Azam Ali. If you have specific thing that you have not understood, you can ask once again. Yeah, post your roll numbers. Okay, roll number 19. That fellow roll number 19, Azam Ali, ask the concept what you have not understand. Yes, yes, I suggest you to do so. You have to complete your records up to 11th week. I hope we have done almost 60% of the programs in your labs. Isn't it 60 to 70% of the programs in your labs? So only very few things they are left out. You just do the practice at home and write those programs in your records as we are completing the concepts. Now pointers we have completed. The suitable programs, the related programs you can do in your, in your compilers. Already most of them, they have smartphones, they have decoder apps, they have PCs, laptops. They can download this Dave CPP from the internet and you can practice the programs in that Dave CPP. Or if you have the Turbo C, in that Turbo C you can practice, or in your decoder app. Anything you can use. Okay, anything you can use and simply practice all the programs related to functions, because in your online classes we have completed the functions concept as well as pointers concept. If you have anything related to, any programs related to these two concepts, complete them. And I suggest you to do all the programs, practice all the programs and write the programs in your records. Okay, after reopening, we can utilize that lab time as well as the class timing to discuss or to revise these concepts once again. From the beginning, we can revise, and all the programs we can practice in the lab, and we can utilize the timing. We can conduct some extra classes, that what we call that quality circle sessions, that class assessment sessions we can conduct, and we can practice in a thorough manner. Okay, don't wait for my call. Complete everything in your program of pointer. Yeah, program of pointer, I have not explained anything over there. Just this indirection operator I have explained over here. The indirection operator I have explained, and the ampersand operator I have explained, the address operator. Address operator is used to get the address of a variable, and indirection operator will make you to get the value from the address. Okay. Okay, thank you guys. Thank you very much. Hope you have another session. Tomorrow we have another session from 11 o'clock. So kindly come online. We'll wind up this entire pointers concept, as well as I'm thinking to complete that recursion as well. Okay, thank you very much.